So in chapter 12.2, part 1, we're going to learn about how to organize data sets into tables, and then from the tables we're going to learn how to put them in graphs. In part 1, we're learning about qualitative variables. Our major objective is to learn how to organize and present data that has labels. So our objective is to construct frequency distributions for qualitative data, construct a bar graph, and we won't be able to construct a pie chart. We did that in class, and there's an example in the book. So in this chapter, we're going to be studying two types of variables. One is a qualitative variable, which we call labels, and some examples are like gender and eye color. Those are labels. The other type of variable we're going to be studying this chapter is quantitative variables, and those are measurement variables. And there are two types of quantitative variables. One is continuous and one is discrete. For both types of variables, we're going to construct a table. So the first step is we're going to construct a frequency table before we actually create the graph. And both of them will have frequency tables. So we're going to spend our time in this section talking about qualitative variables first. And you will notice that the graphs that we're going to be interested in is bar charts or pie charts in this section. When we get to quantitative variables, we will be interested in histograms and dot plots, as well as stem and leaf plots. So once we've created a table, we will count the number of observations by category or class interval. Graphs are based on two formats, or on two axes, the x horizontal, which is going to be our variable of interest, and the y vertical, which is either going to be a frequency or a relative frequency. So here's an example of a bar chart for a qualitative variable. The following chart shows the number of shark attacks by state or country. The x-axis shows the region, and the y-axis shows the frequency. You will notice in this bar chart that it looks like Florida has the most shark attacks, over 350 per year. And then the rest of the regions, Australia, Hawaii, California, Brazil, South Africa, and New Zealand, look like they're around 50 shark attacks a year. Australia looks like the second most shark attack region at almost 100. The least, of course, looks like New Zealand. Well, in order for us to organize the data and then create a bar graph, we create what's called a frequency table. And our frequency table is calculated by category. We call the first column the category column, the X column. And the next one is we would have a tally column if we were looking at actual data sets. This one is called frequency, and these are the number of patients in a particular hospital that was sampled to have different blood types. So once you have the category, you count how many of the patients have the different blood types in this particular example. Once we have the frequency table, we then can create a bar graph. And you will notice that our X variable here is placed on categories. The categories that was in the table: A-type blood, B-type blood, O-type blood, and AB-type blood. And we have the frequency over on the y-axis. So our y-axis is here, and we have the frequency. And you can see that the frequency that we have for blood types is shown in this particular bar chart. So now we can also add one more column onto this particular frequency table, and that's called the relative frequency. So what we do is, here's our frequency column, this is our blood type column, and then we have our relative frequency column. To get the relative frequency, we divide each column's category number, frequency number, by the total frequency, which in this case is 150 patients. So the relative frequency gives us the probability of randomly selecting an individual in this patient population that has a particular blood type. For example, it turns out that in this patient population, 40% of the patients have A-type blood, 13% have B-type blood, 43% have O-type blood, and only 3% have a B-type blood. So once we have the relative frequency, we can also create a relative frequency bar chart. So we put everything over here either in a percentage or in a decimal number to do relative frequency, and you can see our bars are related again to the blood types. Over here is the calculation that you need to have for relative frequency. It is the category count divided by the total count. And if we wanted it as a percentage, we would multiply it by 100%. So why do we want to create bar charts or graphs? One is that we want to interpret the features of the graph to give us some information about our population or about our sample. For example, in the blood type sample, the bar chart shows that the O type is the most common blood type, and about 43% of the sample of the population has O blood in this hospital setting. The least common blood type in this sample is AB blood. As a medical health care provider, this information is important in knowing the population of blood types, especially if you are in the hospital setting. Well, this concludes our first part of looking at qualitative variables. In the next part, we're going to be looking at quantitative variables.